Hi listeners, and welcome to the HVMN Podcast. This is Dr. Brianna Stubbs. We're switching things up here this week, and I'm going to be your host and give Geoff a little bit of time off. This week, we're going to look at the topic of science communication. If you've happened to tune in to my Research Roundup series, you'll find perhaps it can get a bit science heavy at times, and you may find it can be tough to follow along with the medical jargon and terms. And honestly, it can be challenging for me to break down these complicated topics and make them interesting and accessible for people who have different levels of background science knowledge. When we think about the art and science of communication, with science you may need to go even more towards the art to try and bridge the gap between research and public understanding, which has always been something of a pain point. With the inescapable rise of social media and the big uptick in numbers of scientists and influencers in health and performance who are taking to Twitter to share their thoughts and opinions, science communication has changed a lot, and it will surely continue to evolve. I explore this hefty topic with Dr. Paige Jarreau, whose research focuses on the intersection of science communication, journalism, and new media. Along with teaching at LSU, she works at LifeOmic, a telemedicine app that we're going to touch on in this podcast. Paige also practices some of Team HVMN's favourite interventions, such as intermittent fasting and meditation. We chat about both the science of social media and science on social media. We'll give some beginners tips for reading research papers and then discuss some of the challenges that women face in academia. Hi Paige, thank you so much for coming on the podcast today. It's really great to have you.
Yeah, thanks for having me.
No, so really looking forward to our conversation. Perhaps a really good place to start would be, how did you get into science?
That's a good question. So I always loved science from when I was a little kid. Although actually one of the first things I wanted to be was a writer, which is kind of telling. So I said I was going to be a writer, and then I grew up a little bit and decided I was going to be a doctor. And then my dad always read science fiction books to us when we were kids. And then, I started to love science fiction. I read all of Ray Bradbury's books. And so I kind of got into science through that fictional, thinking about, the science writing side of science. But ended up staying in, loving biology, and went to school for biological engineering, actually. And that's really how I got into science.
So what you were doing a doctoral research in biomedical engineering, is that correct? What were you researching as part of your doctoral studies?
Yeah, so I actually did start a PhD in biomedical engineering, but backed down and got a master's in it. And I was studying whether we could functionalize or put DNA-like drugs onto nanoparticles. So very nanomaterials and nanodrug type of research to see if we could change gene expression through these kind of labeled nanoparticles that we put DNA drugs onto.
So this is obviously like a super complicated topic. How, if you sat down next to someone for a drink in the evening, how was your 30-second elevator pitch? Could you sum up that in 30 seconds for us? And then was that part of what led you to wanting to be in science communication a little bit more?
Sure. So for the science side, I would say one really cool thing I ended up working on was these silver nanoparticles. And silver is obviously a metal that, if you imagine shining light on silver, it does special things with light, especially when there's a really, really small piece of it. So the special things that happen with light on a tiny silver sphere, we can use that to change drugs into being active or inactive.
Wow.
So I was working on trying to put DNA molecules on, DNA drugs onto these silver nanoparticles and hitting them with light in a special way that would do special things to the drugs.
Wow.
Yeah. So this kind of the elevator pitch on that. And then as far as what got me into science communication, I was working in a master's program, actually working in a PhD program in biomedical engineering. And I missed having the big picture of, I was working on tiny little pieces of a puzzle. And I really loved the big picture, thinking about why does this matter? And, what's the next steps? And so in missing that, I decided I was going to start a science blog, and really the rest is history. So I started a science blog with what was then Nature's blogging network. And I was writing all about the science of science fiction films. So harkening back to my original love of science and science fiction.
What's something that you think our listeners might be interested in, one of the weirdest science fiction, real science, that you found when you were writing that blog?
I know that I started with writing about Gattaca because that was really cool.
That's a cool movie.
Yeah, it's really cool. And it has it's coming back to being something that we think about now with like CRISPR and all that kind of stuff. But yeah, I think that and the 2009 A Space Odyssey are probably like the most famous examples of kind of really good science in movies. Ended up being kind of predicting what would actually happen in science and tech.
Yeah, I mean, I think it's kind of like an interesting, just to spend a few minutes. So for our listeners who might not have seen the movie Gattaca, it is about this kind of dystopian future where everyone's been like gene edited, and there is this group of people that were not gene edited and they're sort of inferior. And so it's all about finding a match with good genes. And so as Paige said, now we're at a stage where we can gene edit with this technique called CRISPR. So do you think we'll ever get to this like dystopian future like Gattaca? Like, is there any other how good is the CRISPR technology in comparison with what we saw in that movie? And especially with the recent CRISPR baby, right?
Right. Yeah, I'm not an expert on that, so I don't know if I can say as far as where we are on that, being able to do that. But I think Gattaca is a really cool movie because it goes to more than the science. It goes to the ethical and moral considerations that we have to have. And so I think that is very relevant today is, deciding, where, what are our, I guess, guidelines and where are the moral boundaries for things like this.
I guess, so, and taking another like funny little step back, I think when I came into this conversation, I was thinking a lot about how as scientists, we can communicate out to people who don't do science. But then what you just said made me think like, scientists don't necessarily do a good job of integrating like social ethics like back into their research, because this guy who recently did the first ever gene edited CRISPR babies, he kind of stood up, it was this big controversy, and maybe he was pushing the boundaries. It didn't occur to him that people might not want this. So I think we'll get into this more through the conversation, but there's got to be a two-way street of communication between policymakers and scientists, as well as scientists and policymakers and the general public as well. So it's like definitely a complicated thing to try and unpick. So when you moved, you started your science communication program. What does studying science communication look like?
Yeah, so I actually went into a program that was a mass communication PhD. So I was pretty much just straight doing media and mass communication type of research and learning, but I applied it to science always. So, of course, as a mass communication PhD, we had a bunch of classes where we always had to write blogs, we always had to, write papers, whether it was journalism class or a PR class, and I would always apply that to science through my own blog that I was maintaining at the time. So, so I always studied, how these communication principles that I was learning about in communication theories, how could they apply to how to best communicate about science?
And so do you think that nowadays so much of the science reporting is done by people who may or may not have a scientific background? What do you think should be the prerequisites for being allowed to be a science journalist and deliver that kind of message out to the population? Yeah,
I actually believe, kind of being trained in mass communication and journalism, I think there's a lot of skills there that really, if you do it right and you're trained in the correct way, you should be able to write about anything. So, I think any journalist, even without a science background, I don't think having a science background is a requirement at all to write about science and communicate about it. But I think you have to have, you have to want the truth, and you have to search out evidence and data. So whether that's, triangulating and talking to many different scientists, relying on other experts, but in a way that, you question and get, different sources to give you input, with proper interviewing skills, I think anyone can write about science. It's just being really, wanting to get to the core of the truth of what's happening.
So you said a couple of interesting things that I'd like to kind of go into a bit more detail. The first thing is this idea of truth. And I wonder what your take is on how much nowadays people want to convey the truth, or people want to get clicks, and people want to drive traffic to their articles, because nowadays every study seems to have some sensational kind of headline that's meant to make us, click on this newspaper's website, and then we're seeing their advertise. It's kind of like the attention market. So do you think that that's corrupting science communication, and what can we do about that?
I mean, there's a couple of things there. One is the idea that today's media landscape, I mean, people aren't necessarily paying for, I mean, some people are, but largely, we're not paying for hard-hitting, journalism. We tend to expect it for free with considering the social media landscape today. And so it's very difficult, really, for newspapers today to go out and do hard-hitting science journalism because they're not able to pay, a highly trained, in science journalists to go out there and do that reporting. And so it tends to create, and they need to get views to make money, any kind of money for the newspaper. And so it turns into, it's kind of just what's created from the market. And so I think, we all need to consider what we're paying for, and that we get what we pay for, kind of thing, when it comes to science journalism. I think that's why the landscape, it's become that scientists are trying to fill a gap. So now there's professional science communicators, and there's science outreach personnel at universities, and there's, science faculty, and science researchers are taking to social media and to blogs because they see a gap, and they're wanting to fill it with, more evidence-based information.
What do you think are the dangers of scientists having social media presences? Because I see, like myself, that people say things on Twitter that they would never say or never get through a peer-reviewed kind of journal. And so there's almost like this higher level of like science chat that goes on in journals, and then this like open conversation that the public can peer in on that happens on social media that's completely different in tone and can sometimes be kind of scathing or nasty and confusing. What's your take on the ideal way that scientists could use social media themselves?
Yeah, so Dominic Broussard, is a science communication researcher, has a good point on some of those conversations that happen in public. And for scientists to always, I mean, the best rule of thumb is for anyone on social media, including a scientist, to realize that it's not just your peers watching what you do, even if they're the only ones following you on Twitter, that those tweets that you're writing about from your research or your methods, they actually have a much broad, I mean, anyone could potentially see them. So it's really important to, in what you're saying, whether it's to another scientist or not, to think about how that could be interpreted by people that aren't your primary audience. It's basically the key factor in like every social media crisis is not considering, the potential audience of what you're saying instead of only thinking about the one person you think you're talking to or want to talk to.
For our listeners who maybe not scientists themselves, but they're watching and all of these exchanges go backwards and forwards between all the big personalities that they hear on podcasts or that they see they publish research and they're watching, how do they unpick the difference between what people are saying on social media versus what's being said in the science and in the science literature?
Yeah, I think that's really hard. And it's why it's so important, I think, for scientists to engage with the public. So kind of going back to the question we had about, do scientists consider the ethics of what they're doing? And you mentioned it or alluded to it, but it's that active listening. So I am really adamant about, I believe that scientists who are on social media should be willing to engage with anyone who, asks them a sincere question. So if there's non-scientists following you and they ask a question, I think scientists have an obligation to listen and to engage in those conversations, not just with their, peers on social media, because like you said, it's really hard when you're listening into a conversation between scientists on social media and not understanding the context of that. I just think it's important to kind of have a group conversation and to communicate those, whether if you're talking about your research and research that you're doing, maybe that hasn't been published yet, to have it come with caveats and to add some context around it, even if it takes a couple different tweets, so that, a lay audience, someone who's not a scientist who's following you, can kind of get the bigger picture.
It's certainly interesting to watch how it's changed over the years, how people use social media, and interesting to even reflect on how when Twitter changed the character limit, now I still see scientists that have tweets. I read through this thread the other day. There was, I think it was over 60 long. I didn't even read the whole thing. I was like, why are you not writing this on a blog? Twitter is not the medium for a 60 tweet thing. But I mean, So everyone's using it a little bit differently and trying to reach people. It definitely is challenging to try and respond to everyone that wants to weigh weigh in on, especially a controversial topic and thread like that. And it does seem like with the news, with social media, people try and provoke a reaction a little bit.
Yeah.
It almost, so then you've got on the flip side, the peer-reviewed literature, which is, much less accessible, not only in terms of the fact that a lot of it's behind a paywall, but also just the language and everything. It's not necessarily something that everyday people can engage with, but it's sort of the more, high and lofty method of science communication. So I think it might be useful if you and I could just get into a little bit of the background of like peer review and like what happens when a scientist does an experiment and how does that get into a journal. So you've done your experiment, you've got your results, you've written a paper. What happens next?
Yeah, so actually it kind of varies today. I can give an example of, myself and some colleagues have a paper that we're trying to get published right now. And we recently, so we did the experiment, we wrote it up, we did kind of talk on social media about some of the general things we were finding and said, okay, we're going to submit this paper. And then when we did submit it to one journal, it came back rejected. So then we changed it a little bit and we actually put it on a preprint server. So it's a repository or somewhere where you can go and find papers before they've been peer reviewed.
Does that affect the chance of publication? Sorry to interrupt, because I know that sometimes you have to have it be exclusive almost.
So most journals today will accept a preprint on some of the standard preprint servers, but especially ones like PLOS ONE, journals that have Creative Commons or more open access options, which is what we're going for. We want an open access journal. So we did publish a preprint before it has been peer reviewed. And now we're still waiting for peer review at another journal. So it means you submit to the journal and you have other scientists basically in your field who are going to be contacted and they're blinded. So we don't know who they are. They usually don't know who we are. And then they're going to look at our paper and evaluate it and point out any errors that they want us to fix and either accept it to the journal or reject it.
And so what do you think, what do you personally think of the peer review process? And what, you've obviously spoken to a lot of different scientists in a lot of different fields. What's the general feeling about this peer review process where other scientists look at other scientists' work? Do you think that is it doing its job? Is it working?
So it's not perfect. I mean, it's built on human system. It's not perfect, but I mean, it's really the best we have is getting a bunch of experts together and decide, collectively deciding on whether a piece of research has been done correctly and not, and whether it kind of deserves to be published or not. So I think it's super important, obviously. I don't think we can ever get away from peer review. I think that's a very, very, very important process to evaluating research that should be out there and be cited and be followed up on. But whether how we're doing it is right or not, I think there's a lot we could do to make it better. For one, scientists aren't paid or rewarded usually for doing peer review, meaning that I'm a scientist and I am asked to peer review papers. I'm not even a professor. I don't have tenure. I don't get any kind of reward for doing that. Yep. So there's some question of like, how can we reward scientists for at least taking the time to do a good peer review or not? And then now there's models of open peer review. So you can, there's even journals where you give your peer reviews and they go up like comments on a blog post, so everyone can see them, and it's called open or public peer review, and so that's another model where the question is, okay, when the people, the authors of the paper that you're reviewing, if they know who you are, if you know who each other are, and your comments are appearing where everyone can see them, maybe you're a little bit, maybe you take more time in developing your answers, or maybe you're a little bit kinder. And how you say things and give more constructive feedback. So yeah,
because I think I definitely agree with you that it's the best system to be working under right now. But there's definitely these flaws where you're doing it on the side. You may not be giving it enough time. You may not be an exact expert. And personally, sometimes I've been asked to review a paper and they're using a technique that I'm not that familiar with, and I can't tell that easily if they've used the right technique or the right controls and that kind of thing. So I think having a more open discussion and some accountability by having your name out there, that's probably helpful, but then also you get into this like kind of politics question about whether or not, you know, it's a competitor research group or whether or not you personally agree with their ideas or their findings. So there's definitely the human factor is the challenge in, you know, what ideologically should be like quite a good system. So you've got your paper published, it's undergone peer review and it's in the journal. Now then other scientists can find it. I mean, there's almost two questions here. Firstly, how do you make sure that other scientists find it and read it and cite it? And like, as a scientist, how are you trying to like optimize the science reach of your paper? And then what about lay people? So is it then the time to get back to social media? Then should you be, you know, reaching out to science journalists? How does sometimes a finding a really, you know, especially when you look at some of these huge clinical studies that show random associations between heart disease and some particular thing in the diet, and then it's this funny headline in the news the next day. How do we get from the science paper through to the message, both the scientists and then also to the general population?
Yeah, so I think that some of those things blend together, right? So, I mean, there's been research that shows that if a scientist once their paper's published, if they talk to a media professional about their research and they tweet about it, that paper then gets cited more than doing either one of those things alone. Sure. And so, you know, I think it just tells you that it's not just the regular public who's on social media. Scientists are on social media too. We see other people's papers because they tweet about them. And so social media is where we are all living. So if you sharing your research on social media or in a blog post or talking to media professionals about it, it could reach both other scientists and non-scientists alike. I think there's things that we can do to make it more accessible. I personally believe that there's not really any reason to put out, say, a blog post or a lay abstract about your paper and not have it be at least accessible by scientists who aren't in your field. So there's a lot you can do to, you know, when your paper does come out, to do the legwork and to communicate about that paper in very different mediums. So you could write a blog post about it. And going back to your point of whether, you know, you write 50 tweets or a blog post, one of the things I tell researchers is if you're worried that some piece of your research, some point, some finding could be taken out of context, that's a good reason to maybe do a blog post, because in that, you know, you can write 500 words and people can read and stop reading, but you could put it in the context you want to put it in. And at least there's some control there versus if it's a separate tweet, like that tweet could be, you know, shared and then taken out of context.
So, I mean, going back to what you were just saying about, you know, so other scientists are seeing science through social media, and I'm a scientist on Twitter. I follow a lot of scientists on Twitter, and there's always, you know, paper titles and stuff. I mean, it's a little bit overwhelming trying to figure out what's actually interesting and then trying to prioritize in terms of how much time you spend reading an article. So I think, is there a danger that, so I see someone who I kind of know and I follow and I kind of like generally what they do, they post a paper, I click on it, I read the abstract or the conclusions or something, and then I retweet it without having read the full paper. I'm then guilty of perpetuating like lower level of quality control. And I'm just assuming that because this scientist did the work or has shared the work and that it's been peer reviewed, that the quality is kind of high. But do you think that bad science can get more airtime than it deserves because it's well promoted on social media versus good science that may not have a professor or an investigator that's really like, especially given now we're in like a global community, a lot of good research is coming out outside of America, or maybe even not in English as the first language, maybe from China, and sometimes, I don't know whether you found this, you read a paper that's been written by a group in Asia and the English is really bad, and that kind of masks clouds your perception of how good the work is. So how do you think we reconcile quality control with like mass information distribution, I guess is the question here.
Yeah, I think that's hard again, but I mean, we know, and I'm talking to some researchers right now about doing a study on this. I mean, we know that, for example, if a research paper comes out, there's now journals are putting effort into doing making the authors write a lay abstract. So it's not just a scientific abstract, it's like a little kind of accessible summary to go along with the paper. Some will even push authors to do a graphical abstract.
Yeah, I love those.
Paper. I believe now, after paying an artist to do an infographic about one of my papers that came out and how much more that paper got shared, now, if I have a budget, I always incorporate some amount of money to pay like an artist to do an infographic when my study is finished, because I know that will help the paper get shared and get attention. So definitely, I mean, investing in media and, graphics, infographics, little videos, I mean, basically popular media around your research, that's going to make it go further. And yeah, that's going to make it go further, whether it's good science or not. But, at least you're getting it out there to where other people can start to evaluate it. So that's why it's, really important for scientists, as we're, like you said, to reshare something when you haven't read it. The best thing we can do is make ourselves accountable to, read the paper, like really make sure that when we're sharing things that we've kind of at least evaluated to where we think it's good science to share. But it's really interesting, that thing you talked about with like source credibility. I mean, the person is everything. We follow journalists now. That's why we follow bloggers who are scientists, because we've come to trust that, well, if they wrote about it, they probably did their legwork to do a good job. I know if I read an article by Ed Young, it probably had a lot of research behind it. I don't think that's such a bad thing. I mean, source credibility, we can't get away from that. We're going to, we evaluate the message by the messenger too.
No, I think that's a really, really good point. So just going to change like slightly onto reading a science paper, because I think that maybe you'd have some really good insights. So a lot of our listeners are not scientists, but may be like interested in like going on PubMed and trying to dig through some of the science literature that we might be sharing out, that kind of thing. So you click on PubMed and you get the abstract of the paper, and you somehow manage to navigate your way and find the full text of the paper. There's no paywall. You got your science paper. How would you advise someone who's not used to reading science papers to begin when they sit down with that science paper?
Yeah, good question. So if you're not a scientist, I think that, a way to easily read a paper, like the way I start, is always by try to get through the abstract and then get through maybe the first intro of the paper. Usually gives background on some of the concepts that were stated in the abstract. So the introduction to the science paper is usually the most accessible. And then sometimes I'll jump to the figures and the discussion. So oftentimes papers will have figures that you can kind of look and see, is there any data you can start to parse apart there? And in reading the discussion, you'll get a holistic picture. If you're not a scientist, and it can be sometimes very difficult to read the methods section of a paper, but that's where, but it's important, even if you're not a scientist, there's things that could clue you in there about how much you can trust this paper. So if you look at the methods, you should see if this is a health-related paper. Was it done in mice? Was it done in humans? Like, is the animal model? Was it just in cells, in the cell lines in a lab? So you can start to see, at least look for the methods for things you can understand that tell you, what was this? Was this a clinical trial? Did it have 100 patients in it or 5 patients in it? Was it done in mice or humans? And those things can tell you a lot about, put context around, whether you should be, if it's a, paper about keto, whether you should be going out and, following what the paper said, or if it was done in an animal model and needs some more research.
Yeah. One thing that I find overwhelming, and I'm sure that just people who aren't even scientists must also find this overwhelming, is how many science papers there are around. I mean, a topic like keto is like a perfect example, because there's human studies with positive outcomes, animal studies with negative outcomes, there's so many different models, so many different flavors of the diet that are used, so many different durations, and ultimately all of the, you can, with some confirmation bias, you could just choose to look at all the positive results. You could just choose to focus in on all the negative results. It's quite overwhelming. So the way I like to rationalize it to myself is think about like bricks in a wall, and you kind of need to look and see how they're all stacking up. Where's the balance of the evidence going? But do you have any tips on how to form an opinion? Well, I mean, and also as a scientist, it's almost dangerous to have like a fixed opinion. You've always got to be open to changing as the evidence changes. But how do you form a stance? Let's just say like your current thinking today is X on this topic based on quite a lot of confusing literature. How do you prioritize sources.
And but just real quick, I'm on the opinion issue. So this used to be, a stance that journalists had that like, hey, we can totally remove bias and we can just say what's the facts and we can not have an opinion on what we're writing about. It's pretty much impossible. And scientists have opinions. And I think it's important to just acknowledge that and say, yes, we're humans and we have opinions and we feel passionate about some of the research that we're doing. But we acknowledge that and we can set that aside when it comes to looking at data. And if there's new data that comes to light, we're going to question our hypotheses and, go back to the drawing board. But yeah, one thing that's really good to look for is reviews. So systematic reviews. These are basically papers that someone has put together where they look at lots of different papers in a field and they kind of sum it up to this point. And those can be really helpful for a non-scientist because they're usually more accessibly written. And that way you get an idea of, okay, 20 papers in the past found this, finding, 5 found this. And you start to get maybe a path towards what's correct. Another thing I didn't mention, I don't know, I think it's free, but Altmetric has a little bookmark thing that you can put in your browser. And I love this because if you go to a science paper and you push this little button called Altmetric that you put in your Google Chrome, it'll show you all the news articles about that paper that have been written. And one really good thing is to start browsing through all the headlines for those because they're usually let's say New York Times wrote something or The Atlantic wrote something about it. You can start to get okay, there's other headlines here that are very different from each other. And start to crack, source a bunch of different kind of headlines around that, and you can get a good idea of whether this is a controversial topic or whether everyone kind of agrees with what's happening in the paper.
Yeah, that's a really, really great tip and something I definitely advise everyone to do. And personally, I think Altmetric also shows, also shows who's been tweeting about it.
Yeah.
And so you can often I'll end up on there and I'll see, really pro-keto scientist has tweeted about it and said this, and really anti-keto scientist has tweeted about it and said that. So you can at least make sure that you read both people's comments and critiques on the article. Doesn't often help me get any closer to forming an opinion, but at least then you can sort of tap into, make sure that you don't isolate yourself in just one school of thought around a paper. So yeah, I think that's a really, really useful, actionable tip that people could try and pass through science literature a bit more, which is definitely challenging. So we sort of ended up talking a little bit about keto and fasting. You're working on something really exciting in that field. Can you tell us a little bit more about it?
Yeah, so I recently became a director of science communication and social media for Lifomic. It's a health software company that's building cloud tech solutions around precision medicine. So on one side, we're building really powerful platforms that can integrate all patient data into one place. So genomic data, electronic medical records, patient-acquired data, so that researchers can basically do more precise and personalized medicine by putting all this data together and looking for trends. But as part of that, we also were building consumer-facing apps. So we're building apps that people can track various different health behaviors and share that data with their physicians or with researchers. And one of the apps that we've built to kind of play around with making a health app really engaging is an intermittent fasting app called Life Fasting Tracker.
Cool. So what does the app do? What does it look like?
Yeah, the app is really blown it's blown up. It's crazy how many it became much more popular than we thought it would. So it started pretty simple with basically a timer that people can track their fasting and track their mood, as they're fasting. But we also incorporated what we think is really important for healthy behaviors is we incorporated the social component. So there's a reason why people go to, these social media outlets to have conversations with others because, social connectedness is a really important part of our health. So we made our app social. So you can join your friends, you can create circles of people that you want to fast with. And that's been a really key part of our app is that ability to fast with friends, to share, how you're doing, to give advice, to kind of share in this experience together.
Wow, that's pretty cool. So how many users do you have right now on that app?
We have around 200,000 users of the Life Fasting Tracker. which is only in a couple of months since it was launched. So it's really cool to see that. And one thing that I'm doing as a science communicator that I'm really passionate about is building out the educational content in our app and making it very evidence-based. So citing scientific research studies, pulling in experts who, have PhDs in these different areas of metabolism and cancer research, and having them write the content that goes into this app that is being used by people that definitely aren't scientists. And so I think that's a really important and kind of innovative way that we're trying to get research out to people who are just interested in living healthier lives.
Wow. So when people are using the app, you're able to update them with latest science research studies as they come out and really help them understand the benefits of what they're doing.
Yeah, exactly.
Wow.
So we have really good open rates too. When we send people out, we send them little notifications when there's a new article in our learning library. And we're producing articles that are posted at lifeapps.io. But it's all written by scientists, and we cite scientific research. So we're really passionate about making that really rigorous information, but that's accessible. So it's definitely a balance to play there. But I think that it's really helping people that might have come to intermittent fasting through seeing a popular source that maybe wasn't so science-backed, but really learning about okay, what's the science behind this? How does fasting impact my metabolism and my health?
I think that's a really interesting point. So nowadays on social media, there's a lot of people who profess or kind of give health advice who aren't either scientists or clinicians, but they have huge reach and huge following. And so they're affecting what people do day to day. How important are they to the health of our nation, and how do you then sort of start the re-education of people who come at it from this less scientific approach?
Yeah, they are extremely important. So one of the things I do research on the side as well as about trust in scientists. And what's really interesting, I think, and maybe not so much of a good thing, is that scientists have a reputation for being very competent or very, we know that they're very smart, but we don't necessarily see them as extremely warm. Most people don't see them as extremely warm. That's really important when you think about a communicator. We trust communicators in our lives, so people that tell us messages, give us advice. We trust them because we think they're warm. So we think that they share our values. We think they kind of have our back. They understand what we're going through. And unfortunately, for most people, scientists aren't those people. But there are people in their community, their neighbors, their local, maybe even local physicians, their health coaches that they've started following on social media. They trust those people, and so I think those people, whether they share good or bad information makes a huge difference. So one of the things I think maybe we should think about as scientists is, how can we reach out to those people that are having a big reach, for example, in the fasting community and the keto community, just make sure we have open discussions with them about, sharing with them the most updated sciences so that they can share with their followers. And coming from a stance of we really want to have a conversation with you, not that we're telling you you're doing something wrong. Instead, really having conversations.
Yeah, it's a very interesting space, those two fields in particular. I spent a lot of time thinking about it. And recently we were making a response video because someone had posted a YouTube video calling fasting a hoax, and he was going after it in kind of quite a clickbaity kind of way. And so we were trying to bring a bit more nuanced discussion in and around fasting. I mean, it's an interesting example, going back to what I was saying about looking at bricks in a wall. So what type of people do you think should be fasting? What's your evidence-based stance on who is fasting really good for and who perhaps shouldn't be, or where is there still evidence kind of lacking? You mentioned that you've been creating a lot of content. What are you most kind of bullish about in terms of intermittent fasting?
Yeah, so I'm really new to the field of kind of aging science and metabolism. So I definitely have relied on other experts in interviews and reading these scientific papers. And so I definitely don't have all the answers. But one of the things I point out to people is just to make sure they look at well, really like human trials. So there's plenty of animal research around intermittent fasting, and it's really interesting. But what has been done in clinical trials? So even most recently, sharing some articles around prolonged fasting on our social media outlets. We've had some people say, well, we did the prolonged diet actually recently with Walter Longo's prolonged diet, and it gives you some calories every day.
Yeah.
And people will say, well, that's not fasting. You're eating something. But I kind of go back to, okay, in human clinical trials, if you look at any human trials, in human studies around fasting, they usually, and there's a reason for this because it's hard to get research participants to not eat for like anything for a period of time.
Yeah.
Almost all those studies incorporate some amount of calories per day. So alternate day fasting has been studied, and it's usually under 500 calories a day. But, if we look at how intermittent fasting has been studied in trials, it usually is some amount of calories, at some portion of the day. And so I think it's just important to always go back to like, what do we know about what works and what doesn't work in humans, and what do we not know? So we know a lot about kind of alternate day fasting and what fasting can do for like lipid levels, and some things like that. But there's other things where we have to do experiments in animals to look at like underlying mechanisms of fasting. So I think it's just really important to like, first of all, talk to a physician. Second of all, consider the safety of what you're doing. And that goes back to kind of like what feels good for you. Like I think people should be doing fasting in ways that make them feel better, certainly not making them feel kind of symptomatic in a negative way from fasting.
For sure. And do you think now you've got this really big user base in the app, and you mentioned that you're going to be feeding that back into doctor's notes and also into research, have you got any aspirations to run or kind of be part of clinical trials of fasting yourself? Not you personally, but like you as the group in the app.
Oh, yeah. I think that that's one thing we're super excited about. So one thing to just point out for people that are joining our app now, the Life Fasting Tracker, we're super, super strict about personal health information and not sharing people's data. So we're HIPAA compliant and high trust certified on our cloud platform side. So people's data is not shared if they don't want it to be. So right now we don't collect any data for research, but with our new app, Life Extend, that's coming very soon, people will be able to, when they join the app, they'll be able to say they want to be research participants. So they'll be able to say, yes, we want to share our data for research. And in that app, we're super excited about, we'll be tracking fasting too, about asking people to participate in some research studies where we can do maybe some, observational studies ourselves about when people fast, what other health behaviors are changing, what outcomes are they reporting, their mood, simple things like weight, but also more complicated things like other health outcomes.
Well, especially if you have a platform that integrates all of those things at once, it's like super powerful. One of the studies that I enjoyed reading the most over the last year or so is an app that had like a little graphic on it that showed that where you would all you did was input if you were eating something, and so they had like over the 24 hours you could see everyone's eating incidences throughout the day, and that for the first part of the study it was just like mark whenever you eat, so people were just sort of like eating in the night, eating really early in the morning, like eating all over the place. And then the researchers put like a little box on this graphic and they were like, only eat when it's in this eating window. So it was like a way of compressing people's eating windows. And I think they did some like health metrics before this stage, looked at when people were eating, confined their eating windows, and then redid the health metrics. And they could show really powerfully that people were pretty good at like getting their eating windows in this little box, and it actually made some positive differences to their biomarkers. So I think actually like telemedicine and figuring out ways to make it engaging could be really, really powerful, because it brings power into people's own hands and people can really take control of their health. Yeah,
that's one of the things we're super passionate about, is giving that, and it kind of goes back to health and science communication, is unfortunately, I think it's super unfortunate that a lot of people that participate in research and clinical trials never get the results communicated back to them. Like they participate and then it's over, and maybe they got some beneficial, health, maybe they benefited in some way in terms of their health from participating in the research, but otherwise it doesn't come back full circle. And so that's one thing we'll definitely be doing is, anyone who does research with us, and I'll personally be helping, I would love to help train scientists who are working with us in science communication, and helping them, close that loop and communicate back with the patient, sharing, graphs of how they're doing, communicating results of the overall trial when it's finished, that, like you said, that piece of like fitting your eating window into this little box. I mean, that's a very visual thing. Anything you can give back to the person who's using this app that's engaging and visual too can help them, better understand what you want from them and how they can better be helping themselves through their health, and then the outcomes of some kind of research they participated in.
I think a lot of these things probably feed into why people don't trust scientists, because reflecting on like when I've run experiments myself, and I mean, I didn't run like big clinical trials or anything like that. But you're sort of pushed for time. And then also once you finish the research, the analysis and the write-up and the publication, all of this like delays things. And then also there's ethics around, whether or not you should be keeping people's contact details after the study. So, I mean, I guess in an ideal world, like you're saying, you would finish the study and you would have a mail list, private mail list so people can't see one another. But obviously you just like send out the result, the paper, if it was published, but maybe not all research is published as well. So there's sort of problems there about really managing to close that loop up. And so people are signing up for clinical studies, may or may not get the results at the end. And then also during the study, there has to be this, you have to depersonalize things a little bit. People, sometimes they're blinded to the, more often than not, and for good clinical trials, people are blinded to the intervention that they're receiving. So you can see why people don't trust scientists, because they're like, here, take this, and I'm not going to tell you, it's all very clinical, and that's the way that it's mandated for the ethics board. So, I mean, how do you think that we could work within good ethical guidelines for doing these experiments, but engage the people who are doing the experiments better?
Yeah, that's a really good question. And I mean, obviously the safety of the research participants and their health comes first, and then securing their personal data. But I personally think there's great ways that we could, in no way, move into the space of like, problematic issues with ethics and with people's, contact information, but still close that loop. So even, for example, I mean, if someone participates in a research study and maybe some of my research studies in social sciences, it's a bit easier, but you can maybe even have a newsletter at the end where they could sign up, and it's a totally different contact form, and they could just, sign up for some kind of communications to come at the end of the study. It's really nice in a platform like what we have at Lifomic, where we have an app connected to people's health information in a very secure network, is that we can, very securely push health recommendations and information back to them at the end of a study, while being constrained and being well within, ethics board requirements and that kind of stuff. But so I think there's plenty of ways where as scientists, whether it's like we have a blog to talk about, what happens at the end of a study, and we make sure people like they could sign up to follow it while they're signing up for the research study. I mean, I think there's plenty of ways where if we think about, you have to think about the communication up front. That's the problem. So a lot of scientists and researchers, they're thinking about doing their research, and at the end, when it's published, they're like, okay, now what do we do to communicate about this? I think that's the problem, is like, we needing to think about the communication part before you even do the research, like up front. How are we going to close the loop and have this really help people?
Yes, a challenge. And I think that like the younger generation of scientists are starting to become more attuned to, because I mean, we grew up in this era where social media is now like just the way that everyone communicates and the way that everyone lives, like you said at the very start. So maybe we'll start, I mean, I'm sure there's going to be like hits and misses in like how this goes, but hopefully it'll become increasingly a force for good in science communication. And sort of like on that note, I'd love to give you a chance to talk a little bit more about the Scientists Who Selfie campaign that you ran. I saw that, it looks really cool. Tell us about what sparked you to do it and what the outcomes were.
Yeah, so that was a really fun, super fun study, because I kind of came at it from, I just wanted to do some research that involved Instagram, because I did my whole dissertation around science blogging. So how science bloggers, like what their practices are. And I talked to a bunch of science bloggers. I was like, that's cool. I know tons about science blogging, but like, I want to, research a really cool new medium. Let's do Instagram. And so I thought about like, what could I research that involves Instagram? And at that time when I was kind of thinking about what could I do with Instagram for a social science study, I saw a video where Susan Fiske was talking about some of her research where she studies stereotypes very classically, but she had a particular study where she was looking at stereotypes of scientists. And there was that stereotype I talked to you about scientists being perceived as very competent, so very intellectual, smart, capable of achieving their goals, but not necessarily very warm. That means not very friendly, not necessarily being seen as extremely moral, not seen as having your back, sharing your values. And so I was like, that's really interesting. Thinking about Instagram and thinking about like visualizing science. What if you saw a friendly face on a scientist? I mean, we don't normally see scientists, faces. We don't see them in the lab, being human beings. So could putting a very friendly face on science make people, change their stereotypes about who a scientist is, what a scientist does, and the fact that a scientist might look like you and share your interests and your values. So that's really what we did with the Scientists Who Selfie project. We decided we were going to do an experiment and definitively look at people's perceptions of if they saw scientists selfieing or their portraits on Instagram versus if they just saw the scientist sharing a picture of a microscope or a picture in their lab. And how that changed people's perceptions of scientists.
So did you have to consent people to take part in this research and that kind of thing? Was it like a full-blown?
Yeah, of course. So we did an experiment where it was very confined in the lab and then on an online survey experiment. So we got real scientists to help us take pictures and contribute to our experimental stimulus. And then we did the classic, IRB or institutional review board, like ethics committees to give us research participants. But yeah, so we were just basically bringing people into a lab or giving them a survey online and saying, hey, look at these pictures of scientists that is either, pictures of just science itself, like microscopes and stuff, or pictures where you could see the scientist's face. Yeah. And then tell us, what do you think about scientists in general? Do you think these people look very warm and competent? Like, what are your perceptions of these people?
Wow. And so what were the results? Did it make a difference?
Yeah. So both in the lab study and in the online survey experiment, where we actually had a U.S. representative sample of people looking at these pictures, which is pretty good for social science research because we had some good funding. And we found that when people saw pictures of scientists' faces, and so the pictures were very controlled. Where let's say it's a microscope, and then you would see it was like the same exact picture, but the scientist was now you could see their face in the picture. And when people did see those self-portraits of scientists, they not only thought those people were more warm, more friendly, and evaluated them more positively, but it also transferred to their stereotypes of scientists in general. So when we asked them, what do you think about, what do you think? Are scientists generally warm? Are they generally competent? We asked a bunch of different words associated with scientists. And people, these kind of positive views of the scientists in these portraits made people change their stereotypes about scientists.
So I wonder whether alongside the graphical abstract, you should also have to put a selfie in every time that you publish a science article. That would make it, well, I don't know. I feel like that would get me past the first page of a paper, maybe a little bit more. You could draw faces on the ones you don't like.
I didn't think about that. We should add in selfies to the visual abstract.
Well, I know that I saw a paper recently where one of the investigators, I can't remember which journal it was, but they had profiled one of the scientists because I think he was a young investigator. He'd won some award, but as part of the publication, it was a little mini profile picture and a few sentences about one of the researchers. And it definitely, I don't know, it just humanized the paper. I don't know, just so it was made a little bit more accessible. So, and if that's for me as a scientist, I feel like that would be quite a good bridge to continue to break down the walls between, the people sitting in the research orgs and the people kind of at home on the internet trying to learn things for themselves.
Yeah, that's awesome. I would think ideally that humanizing would help people think, hey, I'll reach out to the scientists. I'll ask them a question. I'll engage in conversation and tell them what I think about their research and start to close that loop of public participation in research. And then help people see, especially I think when the scientist shares their motivations, hey, I'm doing this research because, I care about humanity. I want to help people live healthier. I think those sharing our motivations for what we do, I think is super important.
Yeah, I think so. I think the challenge is, though, how do you integrate like all of the different questions, and I agree with you that I want people to be able to reach out and ask questions, but just like finding a scientist, and I don't know how it is always here in the US, but in the UK, you might be running research, teaching, you might be doing like, a million different things, and peer review as well, doing your community service there, and then trying to find time to respond to everyone's questions as well might be kind of challenging, and opinions. So I wonder if there'd be a way to integrate, and, I don't know, maybe if there was almost a service for scientists where it could integrate all the questions that you get on Twitter, and you could do something that we do here as we put out a call sometimes for like, ask me anything, and we'll pick the top sort of 5 of those. So maybe sort of trying to force people to communicate in like a bit more of a set time window might make it something, because otherwise I think scientists can be kind of overwhelmed by all of the things that they're trying to do, especially when you're going like research grant to research grant. There's not always a lot of stability, and so you probably need to figure out ways to build in communication in ways that are doable for you as a scientist as well.
Yeah, I love that. That's a super good idea. But yeah, I'm definitely not blind to this problem that scientists have way too much to do, and we're asking them to do just more and more. So I think that's where we need institutional support for scientists, whether that's, every science lab should have funding to have a, communications professional, or a student who could do some, communications for the lab. I mean, I think there's ways to incorporate this into our grants, into what we do, but it's going to take some structural changes too.
I think that's a great idea. I think it would be so good if it was mandated that in the same way that you have someone that manages your supplies and pipette tips and Eppendorfs and all of that, or maybe that you have someone who's also responsible for maintaining like good lines of communication about the research output of that lab. I mean, maybe even for a whole department, but it'd be good if that person was sort of quite woven into the fabric of the lab, so they understood the scientists and how the research was happening and could give a good account of that. Because I think you're right, the scientists are stretched right now, and you're going to get bad research if we don't figure out ways to manage the load of expectation that there is on them. One thing, and this is kind of like a little bit of a hot, but kind of related, I want to finish up by talking a little bit about women in science, because it's something that I think about a lot. And women in science, you've got all of these things that you're trying to do, plus maybe also extra responsibilities around childcare. And, I don't want to go too much into like women versus men childcare, but what do you think stops women from progressing too far down the like tenure track, or why are women still so underrepresented at the higher levels in terms of academics?
Yeah, this is a really sticky problem, and I wrote about some of this, and I wrote a blog post on my own blog on From the Lab Bench about being female in science, and it's gotten a lot of views and a lot of really good feedback from women in science talking about how those things affect them. And it's really about kind of like microaggressions, the fact that there's not explicit things to say, you can't be a scientist. There tells young women that science isn't for them, or that, there's stories sometimes, but it's largely not very external, like things we can really grab a hold of in terms of I guess discrimination. But it almost makes it harder because you can't, like, those things are, people know that we can't have explicit kind of harassment and discrimination, but then there's all kinds of things that come in that don't get the attention, like just small things that are said in their workplace, or structural things that don't allow women to take enough time off that they need, and that kind of hurts them when it comes to getting tenure in a short window when they might be trying to have families. So there's all kinds of stuff. There's things that, and the problem is that it's all the way along. So in some fields, there's less women going into science, and then if they do go into it, there's discrimination that happens along the way that that kind of at each stage, especially up to the leadership, women and women get less and less well represented. And so especially at the leadership level, becomes really problematic, because if you don't have these women leaders advocating to help women get along that pathway, like along the pipeline, it really breaks down. So I think we need more women in leadership positions in science, so that we can change some of the policies that we don't realize are holding women back. because it's not giving them the things they need in their early careers to kind of make it all the way through into leadership positions.
One thing that you've said throughout the podcast is like really striking, that people don't see scientists as warm. Do you think if there were more female scientists that might shift a little bit? Because I don't want to like go too much into stereotypes, but women stereotypically are like really good, better communicators and warmer or maternal, or some of these things that might make science as a whole profession a little bit less like standoffish.
Yeah, no, 100%. So, I mean, that's one of the things we incorporated into our research, is that we looked at female versus male scientists, and female scientists in these self-portraits were by far perceived as most warm and most influenced stereotypes. So, absolutely. And I mean, and but there's a bunch of problems there, even when it comes to, even if women are equally represented in some field of science. Maybe we say, undergraduate biology students.
Yeah, that's a classical example, isn't it?
There's still, the leadership still is not, it doesn't go all the way up to, let's say, academic leaders in the institution. But even then, like, their representation in the media. So even if there were equal, numbers of women in science right now, they're not as well represented in the media. They're not quoted as often. They're not as visible. And so that's a problem too when that comes to that trust in scientists. It's a big problem.
Well, I mean, hopefully people like you and me, like getting out there and like chatting to one another and like doing good blog posts and good podcasts. So hopefully people will kind of continue to see more and more women out there doing really good scientists, and hopefully that will feed back into the younger generation, and people, young women will be inspired to get into science and stay in science. And maybe if people felt like they could make a difference in science. I think it was funny at the very start, I think you were saying that you were interested in doing medicine for a period of time. And I actually started doing medicine myself. And I think what's attractive about medicine is people want to make a difference. And so I think as science communication gets better, and as there are more women in science, young women, but also young people generally, will see that you can make a difference in science, and it's not just being up in this little ivory tower, like pipetting away and like working out kind of abstract things. Like if there's clear paths from lab bench to translation in some way, then maybe more and more people will be inspired to like get into and stay in science, and make it, and then the communication piece, just making it more accessible, and will be like a smoother pipeline.
Yeah. I know for the article I wrote about these kind of microaggressions that women in science experience, I mean, one of the things, I talked to quite a few grad students who talked about joining a specific lab, not just because the PI, the professor in their lab, was a woman, but because she shared her kind of work-life balance. She shared what it's like to, leave every day to, by 3 p.m. to get her kids, or, and she shared the struggles and how she got to work-life balance. And to these young female students, that was super important to them. They wanted to join this lab because, I think most young women, we realize that like these women who are superstars, and they just seem to they're all career driven, and they're, just doing amazing things. They're not necessarily the most, counter stereotypical examples. They're not necessarily the people that really inspire us. Sometimes that can actually be intimidating. But then as women, we feel this need to, present ourselves as like it's easy for us, and we're, we are superstars and we have it all figured out. I think, admitting the struggles there actually is more inspiring to young women, that like, hey, look, I don't have to be a genius. I can have a family, I can do all these things and still be a scientist.
Yeah, I think that's really important. It's almost like, I don't know whether you've heard of the imposter syndrome, where people kind of are like, oh, I'm just like putting up this front, but I'm not really that competent, but everyone on the outside is sort of just seeing the front, and it's sort of this circle that perpetuates, where you kind of need to achieve to prove to yourself that you're not an imposter, and then you get there, and then there's the next thing and the next thing and the next thing. And I think that women are particularly susceptible to this like circle of feeling like an imposter, and I think having more accessible and honest role models, or being able to have those conversations where you can take your guard down and be like, hey, like I worked really hard to get here, and it's not all been plain sailing, and there are some days where I have like 10 plates and then they all come crashing to the floor. Like that kind of honesty and humanity will definitely be an important part of convincing people to trust in themselves, and commit to a career path that can kind of seem maybe a little bit less certain and laid out for them than others. But it sounds like you have all of this like really great info on your blog. So as we're wrapping up, can you just tell listeners where to find you if they want to read some more about what you've been up to?
Yeah, so on the science communication side, I have a blog called From the Lab Bench, because I went from the lab bench to communication. And that is where you can find all of my blogging around science communication. And then nowadays I'm blogging mostly at lifeapps.io. That's where I do all the blogging around fasting and metabolism and all kinds of science stuff.
Gonna finish up now. Thank you so much for giving us your time. I could have talked to you for like at least another couple of hours, and hopefully we'll be in touch more as you're like bringing out these exciting like telemedicine apps. That's really fascinating. So have a lovely afternoon. Speak to you again.
Thank you.
Thanks so much for tuning in this week, everyone. If you want to learn more about HVMN and our offerings, visit www.hvmn.com/pod. Also, by writing a review on our iTunes page and sending a screenshot to podcast@hvmn.com, we'll hook you up with $15 worth of HVMN store credit. Our last shout out goes to our listener survey, which lets us know who you are better so we can continue making episodes that you find most valuable. So visit go.hvmn.com/podcast survey. For that, it'll only take a few minutes, and new submissions are eligible for an HVMN ketone giveaway. So it's well worth the time. Until next time, study smart, train hard, and live well.